Welcome, welcome one and all to YouTube's most trending channel. That's right, AP Statistics is very entertaining. And today we're going to start chapter 5. Okay, the first 4 chapters, we have been handed data and we've done calculations with it. We've made graphs with the data, but we've never questioned, is it good data? And that's really what chapter 5 is all about, collecting good data. So after chapter 5, hopefully you would know how to collect your own data, and hopefully you would also be able to look at data collection methods that have been employed by others and potentially find fault. So today's lesson, how do we design a sample? Okay. That's, in other words, how do we collect data? Because we have sample data and then we have census data. A census is, of course, if we get data from every member of a population, and that's pretty darn rare because it's usually too costly, too time consuming to accomplish. Our government attempts to do it every 10 years, and yes, this is 2020. This is one of those years where we are attempting to gather census data. So anyway, let's talk about how we can design a sample. Okay, so a sample is simply a subgroup of the population. Okay, we, again, are not collecting data from everyone when we're conducting a sample. The idea is if we collect a good representative sample from the population, we can then use that to infer things about the population as a whole. Okay? So that's why it's really important that we use a method of data collection that will get us a representative sample. So the way that we collect that data, the method of asking people, or doesn't have to be people, but the method of data collection is called the design. Now it's important when we make our design that we use randomization, okay, a probability sampling design. This is going to help us avoid error or systematic bias in our data. By the way, this lesson's pretty much all vocabulary, so make sure you guys are reading your books, and when you come across words that you're not sure of, make sure that you spend some time and learn the definitions of those words. A lot of students misuse words in this unit, and then they lose points on their free response sections. Or they don't understand the words, so when we ask questions in the multiple choice format, they don't understand what's being asked. So you've got to learn the vocab. All right. So the simple random sample, this is kind of the go-to, most straightforward way of creating a probability design. A simple random sample simply gives every single possible sample of whatever size you're interested in the same chance to be chosen. The easy way to do it is you give every member of the population a single unique number, and then you randomly select numbers. So, for example, if I have 30 students in my class, I would number my students from 1 to 30, and then I would use a random digit table or a random integer function to select from that number list. Okay, and that's called a simple random sample, or SRS for short. Okay, another type of sample that's fairly common is called a stratified random sample. This is used when our population has groups that could be very important to the outcome of our survey, and we don't want to or underrepresent any particular group. Because the simple random sample, it's so random that we could end up accidentally, without even knowing, over or underrepresent an important segment of our population. So when we know that there's potential groups that are very important to our question, we might purposefully set things up so that we get a sample that is representative of each group. So for example, let's say I think that freshmen, sophomores, and juniors and seniors have very different viewpoints on whatever topic I'm investigating. I could then set up a stratified random sample where I make sure to ask 25% freshman, 25% sophomore, 25% junior, 25% senior, to make sure that I'm not overrepresenting any one group. Okay, so that is called, again, a stratified random sample. Notice SRS, we can't call it SRS. That has already been used. So when we say SRS, it is specifically a simple random sample. If we want to talk about stratified random sample, then we use the words. Okay. Next, we have the idea of multi-stage samples. Oftentimes, we have populations that are very, very large, and trying to do a simple random sample just wouldn't work, right? Imagine just say the population is the state of California. We have over 30 million people in the state of California. It's not practical to give every single individual a unique number and have this list of over 30 million individuals with their numbers and then use a random integer function. It would just not be practical. It would take too long. And that's just the state of California. Imagine if we were interested in all of the United States or all of Europe or all of Africa, etc., so forth. So what we want to do when we have a overwhelmingly large population is a multi-stage sample. So before we start assigning numbers to everyone, we try to break things down and get a more manageable subset. So maybe our first technique is we use a stratified random sample to break things down. Or maybe our first sample is what we call a cluster sample. Okay. Maybe our first sample is a systematic random sample to kind of whittle down the overwhelming number of people in the population. Okay, so these are more vocabulary terms you need to read about in your book. I'll give you an example here. Systematic random sample. This is used quite a bit by teachers. They'll number students 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 throughout the room, and they'll say, okay, everyone who got the number 1, you come over here. Everyone who got the number 2, you go over there. Everyone who got a number 3, you go in this group. That's called a systematic random sample. Is it random? Yes, that's why the word random is there. But it's not a SRS. Again, systematic random sample. SRS is, but we call it systematic. SRS only refers to simple random sample. So it's not a simple random sample because we are guaranteeing that everyone with the number 1 always goes in the same group. I'll never create some group where there's a 1, a 2, and a 3. It's always all the 1s, all the 2s, all the 3s. You see, so there are certain groups that have a 0% chance of being selected. Okay, but if I choose one of those 3 groups, I still have given everyone a 1 in 3 chance of being selected. It's just that I cannot get any possible grouping. So that's systematic random sample. Okay, cluster samples, those are oftentimes geographic. So in a school environment, I might say, oh, let's just select all the odd numbered rooms in the math department. The students are already clustered into those rooms. Or out on the campus, let's just select all the students that are over in whatever area of the campus. because they've clustered themselves together. So that's why we use that word, cluster sample. Okay. But there are many other types of sampling, so make sure you read the book and learn all the different types. Oh yeah, here's another type, voluntary response. Okay, so the reason we are talking about this is really because we want to avoid bias. Okay. Bias in our data means we have bad, useless data. There's no correcting for bias. I'll give you an example. Years ago, I had some students that were interested in reading habits. So they said, oh, Mr. Crow, here's what we're going to do. We're going to go to the library, and we're going to randomly ask every third person that walks into the library about their reading habits. Hopefully, everyone sees that that's going to have bias, because not everyone goes into the library, right? We're leaving out a huge segment of the population, and it turns out that possibly people that spend more time in the library might read more, right? So we have potentially biased our results there. So that's our goal. We want to avoid bias. We want to make sure that we're getting a representative sample. Okay, we want a sample that covers all of the different groups proportionally. Okay, make sure you know the definition of this word bias, by the way, very important term. Okay, now two types of samples that are used very prominently are convenience samples and voluntary response samples, and both are prone to bias. A convenience sample is simply that word, convenience. What's the most convenient way to get some responses? Okay, go do that way. And that's usually gonna not give you a representative sample. So, for example, if you're out and about during the day, and that's when it's convenient for you to collect your data, you're now ignoring everyone who, say, works at night and sleeps during the day, right? We've now left out a segment of the population. All right, voluntary response samples. These are the types of things that you're constantly getting online. You're always bombarded with, hey, fill out this survey. Hey, answer this question. Well, those are voluntary response. Typically, the only people that answer those types of questions are people that care strongly about that issue. So you're not getting a representative sample again, right? You're only seeing those really strong opinionated responses, which might actually be a small segment of the population. Who knows? So these two types of sample methods, although they're used a lot because they're pretty easy to get data from, they almost always result in bias. So these people who are collecting their data that way are pretty much wasting their time, because biased data is useless data. Okay. I've kind of focused on talking about human populations, but realize we can do random sampling of non-human populations as well. But a lot of times we are, of course, interested in human populations. So here are some types of bias that occur pretty frequently, really, when we try to gather data on human populations. Okay, first type here is called under coverage. And just as the word says, it means that we are under covering a certain segment of the population. Okay, an example would be the homeless. Oftentimes, we send out our samples through the mail. So if someone doesn't have a mailing address, they are not covered by this method. Okay, and that would be an example of under coverage. Okay, another type of bias is called non-response bias. Okay, this is different than under coverage. In non-response bias, you've successfully covered all segments of the population. It's just that some are choosing to ignore your survey or ignore your whatever it is. They're not responding. Notice not responding is different than not being given the opportunity to respond, right? In under coverage, there's no opportunity to respond. In non-response, people are being contacted and they're choosing freely to not respond. Okay, and this is very prevalent in today's society. A lot of people choose to ignore what they get in the mail. A lot of people choose to ignore phone calls for telephone polls, so on and so forth. So non-response is very prevalent. Okay, those two are very clearly named, so most students can remember those. The next one is called response bias. Okay, and this one's a little more vague based on its wording, what it could mean. Okay, but here's what it means. Response bias simply means being untruthful. So for example, if I am asking questions about, say, illegal drug use or other illegal activities, human populations are very likely going to be untruthful. And that would be called response bias. Okay. So we have to try to avoid response bias whenever we deal with any sensitive issues. Okay. At the end, I have a little video, a little Saturday Night Live clip, and I'd like you to watch it and try to pick out the bias that occurs in the clip. Okay, another type of bias that happens with humans would be question wording. When we poorly word our questions, we can get inaccurate answers. So the wording could be confusing to the person trying to respond, right? Maybe it's written with double negatives. Maybe it's worded in such a way that the average poorly educated American can't understand. Maybe the vocabulary is too advanced for many Americans, so on and so forth. So, or it could be a leaning question. A lot of times, especially in politics, certain groups have a platform and they will purposefully word their questions in a way to try to sway the answer, and then they can point to, 80% of Americans agree with us on this issue. So you got to be very careful about data when people are responding to either written or verbal questionnaires, and make sure that the wording of the questions is not influencing the responses. Okay, and that's what we said here. Okay, we must be experts in how we choose our samples, how our questions are worded, and so on. Okay? All right, so that being said, at this point, I'd like you to go ahead and watch the Saturday Night Live skit. It's about census takers. And yes, there are such things as census takers. This year with, of course, COVID, there have not been, people going door to door like in the past, but this is something that has happened many, many times to try to track down people that do not return their census information, because again, our government is trying very hard to get the most accurate data it can about our population. So check out this video and see if you can pick out the various issues that occur in gathering the data from this particular individual, and think about how that plays out, not just for one individual, but across an entire sample. Thanks for watching.